There's something even more fascinating. This brave spacecraft is not only miles, but millions and millions of miles from its launch point. And yet, it continues to send invaluable data back to Earth. What's truly remarkable is that it does this using technology older than that of a cassette player. Imagine that for a moment. A machine launched in the late 1970s, armed with primitive computing and basic communication systems by today's standards, is still out there relaying messages across the vast cosmic sea. And that's not all. The spacecraft, which was launched in 1977, just made a discovery so compelling, so profoundly mysterious that it is shaking the scientific community to its core. It has captured the attention of the entire world, igniting both scientific debates and public imagination. What could this amazing find in the far reaches of space possibly be? And perhaps more intriguingly, what does it mean for us here on Earth? There was a key moment in history, an inflection point, when two of the most amazing space missions ever launched by humankind ushered in a brand new era of space exploration. These were not merely missions. They were 2's, journeys into the unknown. This revolutionary turning point was made possible thanks to the brilliant and forward-thinking mind of Gary Flandreau, an engineer at NASA's Jet Propulsion Laboratory. His innovative thinking led to a historic breakthrough. With only a pencil, paper, and a 20th-century engineering mindset, Flandreau made a startling discovery. During the late 1970s and early 1980s, an extraordinarily rare and favorable planetary alignment was due to occur, an alignment of the four gas giants, Jupiter, Saturn, Uranus, and Neptune. They would position themselves in a unique cosmic configuration like celestial beads strung on an invisible necklace with Earth dangling at one end. This rare cosmic dance was no small matter. It would allow spacecraft traveling close to each planet to gain speed using each planet's gravitational pull, a technique known as gravity assist or gravitational slingshot. It's as if the spacecraft were being pulled along by an invisible rope, gaining velocity with every planetary pass. This brilliant maneuver could drastically cut down the travel time through the solar system. A journey from Earth to Neptune that would ordinarily take 30 years could be reduced to just 12 years. This wasn't just a clever trick. It was a once-in-a-lifetime opportunity. Literally, this particular planetary alignment occurs only once every 176 years. Faced with such a fleeting and extraordinary chance, NASA knew it had to act fast. With incredible speed and precision, and only 15 days apart, they launched two identical spacecraft, Voyager 1 and Voyager 2, during the summer of 1977. Their mission: to take advantage of this rare cosmic window and explore the outer planets in a way that had never been done before. Little did NASA know at the time that these twin explorers would go on to break every conceivable record in the history of space missions. More than 45 years after their launch, both Voyager 1 and Voyager 2 are still operational, still sending back data, still going strong at the farthest edges of our solar system and beyond. These probes have become the farthest human-made objects in history, having traveled far beyond what was initially imagined, especially considering their original mission was only supposed to last 4 years. However, these interstellar pioneers were full of surprises. At the beginning of their journey, they delivered astonishing close-up images of Jupiter and Saturn's moons. These were not dull, inactive worlds, as once believed. They were dynamic, complex, and teeming with activity. Some had volcanoes, while others had vast frozen plains and mysterious atmospheric conditions. The discoveries forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, achieved historic milestones. It became the first spacecraft to approach Uranus in 1986 and Neptune in 1989. These encounters weren't just technical successes. They were landmark scientific events, providing humanity with our very first up-close look at these ice giants. Before that, they were little more than blurry orbs seen through telescopes. Voyager 2's journey turned speculation into knowledge, uncovering astonishing findings from territories that had remained completely unexplored. The spacecraft traveled more than 14 billion kilometers from Earth, boldly going where no probe had gone before. Despite their modest size, comparable to that of a Volkswagen Beetle, these probes defied expectations. They not only survived the harshness of deep space, but continued to expand the boundaries of our knowledge. Their voyage began with a maneuver around Venus, leveraging its gravity, a feat never before attempted by any spacecraft en route to Mercury. This alone cemented their legacy as trailblazers. To reach Jupiter, the Voyagers traveled a distance more than 10 times the stretch from Earth to Mercury. And to do so, they had to pass through the treacherous asteroid belt, a region filled with debris and potential hazards. While Pioneer 10 and 11 had previously braved this celestial minefield, it was still an incredible achievement. The spacecraft had to rely on their onboard intelligence, all powered by computers with a mere 69 kilobytes of memory, a fraction of what even the simplest smartphone holds today. Data collected by instruments aboard each Voyager was stored on track tape recorders before being transmitted to Earth using a transmitter that operated on just 23 watts, about the same as a standard light bulb. These probes were equipped with 12-foot diameter satellite dishes to facilitate communication with Earth. Using radio waves that traveled at the speed of light, they continued to send and receive signals. But the ever-growing distance made this increasingly difficult. Each day, they moved 3 to 4 light-seconds farther from Earth. Over time, signals began taking more than 18 hours to reach us. An additional challenge was the increasing background noise generated by radio towers, televisions, cell phones, and other Earth-based sources. These noises began to interfere with the faint signals coming from the Voyagers, making it ever more difficult to hear their whispers from deep space. And yet, despite all these hurdles, the Voyagers endured. They kept transmitting data, unveiling unexpected phenomena in the interstellar void, and consistently surprising scientists with new and puzzling discoveries. Their journey has done more than just provide incredible photographs or intriguing scientific data. It has fundamentally reshaped how we view the universe and our place within it. Beyond our own solar system lies a mysterious region known as the Oort cloud. This vast shell of comet-like objects is held together loosely by the Sun's gravity and extends all the way toward the nearest stars. Although the Voyager spacecraft are still making their way slowly toward this enigmatic boundary, they began their entry into true interstellar space when they crossed the heliopause. This is the outer boundary of the heliosphere, the vast bubble-like region of space dominated by the solar wind and magnetic field emanating from the Sun. Beyond it lies the interstellar medium, a different and largely unknown environment. But as Voyager's signal vanished into that mysterious hush, so too did the comfort of familiarity. Earth's instruments, calibrated across decades of reliable, methodical science, began returning fragmented readings that made no sense. Gravimetric data fluctuated as if space-time itself was shifting. Magnetometers picked up patterns that resembled neural activity rather than cosmic radiation. The Deep Space Network, typically precise down to the microsecond, suffered inexplicable lags and echoes, as if its own messages were being mirrored back by an intelligent system beyond the void. A hush fell across the control room at JPL. Rows of engineers and scientists, once casually monitoring pings from interstellar space, now stared in silence at screens filled with incomprehensible data. One of them whispered a word no one wanted to say aloud: response. For a signal, no matter how complex or garbled, to echo back with such precision, it suggested interpretation. It suggested intent. In the following days, Voyager 1's coordinates, plotted by NASA's top astronomers, showed an impossible anomaly. Rather than continuing along its expected path through the heliopause, it had veered, not subtly, not due to gravitational influence, but sharply, deliberately. It was as though something had grasped the probe and guided it. Worse still, telemetry began to reveal something even more bizarre. The probe was accelerating. No known force could account for this, not out in interstellar space. Solar wind had long since lost influence. There were no gravitational slingshots, no nearby stars or planets. And yet, the probe was moving faster and faster toward an uncharted region, a dead zone according to past astronomical surveys. A patch of space so devoid of starlight it was called the Black Fold in hushed tones by some of the more poetic astrophysicists. The scientific community reeled. Theoretical physicists scrambled for explanations, invoking everything from dark matter fluctuations to topological defects in spacetime. But none of the models held up under scrutiny. Something had taken Voyager 1. Something had reached out in the dark and pulled it into its grasp. Then came the real shock. The probe began transmitting images. Voyager 1's imaging systems, long thought inoperative or degraded beyond use, suddenly powered back on. Not just active, they were capturing visuals of an environment no one had ever seen. The first image was a blur, a shifting field of black and iridescent colors, like oil on water viewed under polarized lens. The next was clearer, a structure. It hung suspended in the void, enormous and faintly glowing, like a cathedral made of crystal and shadow. It was not a natural formation. It was too symmetrical, too intentional. Towering spires reached out into the dark like antennae or tendrils.